2D, division of whole numbers. Now, just like subtraction was basically the undoing of addition, division is the undoing of multiplication. Basically, division is dividing or splitting or breaking things up into even parts. And when you do that, the result of division is the quotient. Now, when dealing with division, you do have a dividend and a divisor, and I'll show you where those are. And we need to know that because a divisor is what's doing the dividing or breaking apart the dividend. So when you're dividing, there's really there's a few basic ways of showing division. There's 4 divided by 3, or there's 4 divided by 3, or there's, and this is the one that throws people off, 4 divided by 3. These are all the same. In this case, all 3 of these cases, 4 is considered to be the dividend. And 3 is considered to be the divisor. And the result, of course, will be the quotient. So the result is the quotient. But I point these out because 4 divided by 3, which means we're saying how many times does 3 go into 4? 4 divided by 3, how many times does 3 go into 4? And 4 divided by 3, how many times does 3 go into 4? And I say, like I said, this is the one that people get thrown off on. People have a tendency to write this one backwards and then they get the wrong answer. 4 divided by 3, 4 divided by 3, 4 divided by 3, and people tend to write it the other way as 4 divided by 3, which is wrong because you're dividing the outside number into the inside number. But I just want to make that clear from the get-go as we get into this. So let's erase these and do a little bit of division. So division is, like I said, just breaking things into even parts. So let's say I have 15 divided by 3. And I want to find the answer to this problem. Well, we can go visual on this, right? We can say, I've got 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I've got 15 of these. And I want to divide it by 3, or I want to divide them into 3 equal parts. Well, doing it like this, that's a little bit difficult. But what I can do is to make this visual, here, and I can just make myself these sections. And I can just start dividing this. So it's kind of like when you were in school and they said, okay, count off by 3s. And you went 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, right? And then they had the 3, you had created your 3 teams, so 2 of them went and played and the other team watched, and then you swap in the other team. You know the deal. So same thing here. Can I do that and say, okay, first one goes here, next one goes here, next one goes here. First spot, second spot, third spot. 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 And I've gone through those 15 and I split them into 3 groups of 5. Right? There's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's really what we're doing here is we're just taking this number and saying, okay, how many of these can I make? Or how many, if I divide it by this, how many will be in each group or division of it? So that's a visual of it. Well, remember, this is just the undoing of multiplication. So if I want 15 divided by 3, I'm really asking myself, 3 times what equals 15? So I'm just going to write that. 3 times what, put a question mark in here. People prefer question marks to letters. You start putting letters in and people panic and they go, algebra, I don't like letters. Whereas I put a question mark, they just, oh, 3 times what is equal to 15. Now, if you have practiced your multiplication tables, then you know that 3 times 5 is equal to 15. So 15 divided by 3 is 5. Right, so 3 times 5 is 15, then 15 divided by 3 is 5. Remember, it's the undoing of it. So you're taking what was your product in multiplication, and you're saying, okay, if I have the product, I have one of the factors, what's the other factor? 3 times what is going to give me 15? Now, again, I want to point out, and believe me, this is the last time that I'm going to write it on board pointing it out, factmonster.com /math /flashcards. Okay, that or some other flashcard site to practice your division facts. So basically taking 2-digit numbers and dividing them by a single-digit number to get a single-digit number. Get some practice on it, get good at it. The main thing is you really want to make sure that you're good with multiplication of single-digit numbers. Because if you can multiply single-digit numbers and you know what the result is, then you can divide by a single-digit number because you recognize, oh, this times this is equal to that. So multiplication is critical, division is helpful, but if you can do the multiplication, then you can do the division. It's just reversing the process. So that's basic division, but that's single things. If I go 72 divided by 8, then if you remember your math facts, you go, oh, 8 times 9 is 72, and you go 9. 30 divided by 6 is equal to 5, because 5 times 6 is 30. So that's our basic division. But what if we get into things that are a little more complicated? $126 divided by 9. Well, no single-digit number multiplied by 9 is going to give you 126. 9 times 9 is 81, so it doesn't go that high. So how do we do it if we have something bigger than this? Well, that's where long division comes in. I know some of you are going, long division, I hate long division. Long division is just a repetitive process to work through a longer division problem. It's still the same steps as the problems that we just did. 30 divided by 6 is equal to 5. We're just going to extend it out. So that's going to be 126 divided by 9. Now remember, be careful to get the divisor on the outside. The dividend, 126, goes inside. The divisor, what we're dividing by, goes on the outside. So here's the process for long division. How many times does 9 go into 1? Well, it doesn't. How many times does 9 go into 12? Well, it goes in once, right? I can take away 9 from 12, but 9 times 2 would be 18. I can't take 18 from 12, so it goes into 12 once. So then I go 1 times 9 is 9. Right? I'm taking 1 9 out of it. So 12 minus 9 gives me 3. So I divided 9 into 12. It went in one time, leaving me 3 left over. And then I'm going to bring down this next digit, 6. How many times does 9 go into 36? 4 times. 9 times 4 is 36. So I subtract and I find out I have nothing left over. So 126 divided by 9 is 14. So the method is pretty straightforward. It's just a process that we go through. So let's try another one, except this time I'm not going to write it up here. I'm just going to do the division. And we'll see what happens. 635 divided by 5. 5 goes into 6 once. 1 times 5 is 5. 6 minus 5 is 1. Bring down the 3. 5 goes into 13 twice. 2 times 5 is 10. 13 minus 10 is 3. Bring down the 5. 5 times 35 is 7. 7 times 5 is, 5 goes into 35 7 times. 7 times 5 is 35. 35 minus 35 is 0. So the process continues the same way. Well, what happens if we make a mistake? What if we choose the wrong number? Well, let's take a look at that. I'm going to leave this one right up here, but I'm going to make an oops along the way and see what happens. So I have 635 divided by 5. Well, obviously 5 goes into 6 once. 1 times 5 is 5. Subtract, I get 1, and I bring down the 3. How many times does 5 go into 13? Let's say it goes in 3 times. 3 times. 3 times 5 is 15. 13 minus 15, whoops. I can't take away 15 from 13. Can't do it. So this number must be too high. So then I would take it down. I'd say, nope, that didn't work. Well, what if I take it down to 2? 2 times 5 gives me 10. 13 minus 10 is 3. Bring down the 5. How many times does 5 go into 35? I think 5 goes into 35 6 times. 6 times 5 is 30. So I subtract 30, I get 35 minus 30 gives me 5. Now I notice I've got another oops, because 5 still divides into 5. So notice there's 2 things I could catch by making a mistake here. One, I could catch that, wait a second, I can't subtract my number from the number that's there, therefore I must have chosen a multiplier that was too high, so I can't do that. The other thing is, if I choose a number too low, the result when I subtract is still going to be able to be divided by that. 5 goes into 5 once. I missed 1. So that wasn't 6. That should have been 7. 7 times 5 is 35. I subtract and I get 0, and now I'm happy. So we want to take note of that we can catch ourselves along the way. If we make a mistake, that's okay. We can catch it and say, well, wait a second, if I can't subtract it, I must have made the number too big. And if the number that's left over is bigger than the number I'm dividing by, then I chose a number too small. So it's really handy that we can look for those things. Me, I look at those and I call those sanity checks. Sanity check is when you look at it and go, does this make sense? Could this really happen? And that's where we're catching ourselves. So, very important to try those things. Another thing dealing with division is sometimes things don't divide in evenly. So we have what's called a remainder, what's left over. And we actually saw it in our long division. Because every time we did a division, we said, how many times does this go into this? And then we multiply it back and we said, and then we subtracted, we came out with some number left over. That number was a remainder of that division operation. So what we're going to do now is we're going to do that, but maybe when we divide, we're going to be left with a remainder. Think of it this way. What if I have 18 candy bars that I'm going to share amongst 3 of my friends? Well, actually, no, make it 5 of my friends. So I'm going to share it amongst 5 of my friends. And I want to know how many candy bars am I going to give each one. So I can do my 5 groupings here. Make myself my dividers here. Boom, 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 boom. So I've got 18, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I've given my 18 candy bars out to my 5 friends, and if I'm trying to divide them evenly, you notice that each one can only get 3 candy bars, and then there's these 3 extra candy bars left over. Which is nice because then I can have 3 candy bars, so I give them to my friends and I still get it some too. But this 3 would be considered a remainder. We find out that 18 divided by 5 gives me 3 with a remainder of 3. I can give each one of them 3, and then there are 3 left over. So that's a remainder. Let's expand this out to our long division and see what happens. 314 divided by 7. How many times does 7 go into 3? It does not. How many times does 7 go into 31? 4 times. 4 times 7 is 28. 31 minus 28 gives us 3. Bring down the 4. How many times does 7 go into 34? 4 times. 4 times 7 is 28. 34 minus 28 is 6. We have nothing else to bring down. Since we have nothing else to bring down, that is what's left over, our remainder. So we have a remainder of 6. So 44 remainder of 6. And that's all the process is. It's the same as our standard long division, but when we get to the end and we run out of numbers here to bring down, we still have something left over. And note that it's smaller than this, so I can't divide that 7 into it. So I have a remainder of 6. If I have 314 items and I divide them into 7 groups, I can have 44 items in each group with 6 left over. So that's dealing with remainders. And that's the process. So that's the only thing. When you get done, you don't end up with a 0, you end up with something left over that we call the remainder. It's what's remaining. Another thing that's very important to understand with division is how 0 affects division. We didn't really mention it with addition and subtraction, but 0 doesn't really affect addition and subtraction. Add a number to 0, a 0 to a number, or a number to 0, and you just get the number back. 5 plus 0 is 5. Subtract 0 from some number, you get the same thing back. 7 minus 0 is 7. We just kind of took that for granted. Multiplication, I pointed out that anytime you multiply a number by 0, you're going to get 0 as the result. Well, division we have to be careful of because there's two ways that 0 could come into a division problem. We can have a number, 5, divided by 0, or we can have 0 divided by some number, such as 5. Now, these are going to yield two different things. If we take 5 and divide it by 0, we're saying how many times does 0 go into 5? Well, let's think about that. How many times does 0 go into 5? Isn't 0 just really taking away repeatedly? So if I have 5 and I take away 0, what am I left with? 5. If I take away another 0, what am I left with? 5. If I take away another 0, I'm still left with 5. Taking away another 0, I'm still left with 5. Another 0, I'm still left with 5, right? So how many zeros can I multiply together to get 5? Well, actually, I could multiply an infinite number of zeros together, and I'm still not going to get to 5. So if you have a number divided by 0, then the result is undefined. Well, if you think about it, we said when multiplying, any number times 0 gives you 0. So if we were thinking of this as a multiplication problem, 0 times what number gives us 5? There is no number that I can multiply 0 by that gives us 5 because any number multiplied by 0 gives me 0. So it can't happen, so this is undefined. You cannot divide by 0. Let me state that again. You cannot divide by 0. I'm going to put that on the board. You cannot divide by 0. Give it an exclamation point, okay? You cannot divide by 0. If you're dividing by 0, it is undefined. It cannot happen because you can't multiply any number by 0 and get an actual number. You're just going to get 0 again. So you cannot divide by 0. Whereas 0 divided by 5, if I take 0 and divide it by some number, well, how many times does 5 go into 0? That's what it's saying, right? 0 divided by 5. How many times does 5 go into 0? It goes in 0 times. And no matter how far I go, how many zeros I have there, it's still going to go in 0 times. It can't. So 0 divided by 5, or divided by any other number, is 0. So those are two things to take note of and be careful of. Any number divided by 0 is undefined. 0 divided by any number is 0. 0 divided by 7, 0. 0 divided by 462, 0. 0 divided by 1, 0. Any number divided by 0, undefined. 7 divided by 0, undefined. 467 divided by 0, undefined. 0 divided by 0, undefined because you can't divide by 0. So keep that in mind too. 0 divided by 0 is undefined. By definition, we cannot divide by 0. If any number divided by 0 is undefined. So don't look at 0 divided by 0 and go, that's going to be 1 because it's the same thing. It's undefined. Anytime you divide by 0, it's undefined. And you also run into a paradox here that any number divided, and I'm just going to use a variable in there, a letter, because it's true for anything. Any number n divided by 0 is undefined. 0 divided by any number n is going to give us 0. So we end up with this paradox that anything divided by 0 is undefined. 0 divided by any number is 0. So we take 0 divided by 0, it needs to be undefined and 0 at the same time. which means it's undefined. You can't get an answer to that. So the dividing by 0 being undefined overrules everything else. So that gives us division by a whole number.